We are doing some calculations from balanced equation. This does not involve limiting agent questions. Limiting agent questions comes in the next video. So what is a balanced chemical equation gives information about. So consider the decomposition of potassium chloride, KClO3. So write a balanced chemical equation. KClO3 gives you KCl plus oxygen. So what I understand from this, 2 moles of KClO3, potassium chloride, produces 2 moles of potassium chloride and 3 moles of oxygen. I can use this information to find the approximate number of moles produced. I say approximate because this is a theoretical yield. In actual case, it may not. We cannot get 100% efficiency. May not get 100% efficiency for any number of potassium chloride. So an example is if I have 4 moles of potassium chloride, how much of oxygen I will get. How to set up the equation is write down moles of oxygen, and since the question asks for 4 moles of KClO3, write that down and then convert that using the equation into moles of oxygen. So the 2 moles of potassium chloride will come on the denominator and 3 moles of oxygen comes on the numerator, and this part 3 and 2 has been taken from the equation, and that comes as 6 moles of oxygen. The previous one was in terms of moles. Let's see what information you get in terms of mass. The same equation, and then in this case I want to calculate the mass of oxygen and KCl produced from 60.0 grams of KClO3. So therefore, to calculate the mass of oxygen, start with the mass of potassium chlorate, convert that into moles of potassium chlorate using the molar mass, and then use the equation and convert that into moles of oxygen. So that's why I have 3 moles of oxygen to 2 moles of KClO3. So once I have the moles of oxygen, I can convert that into grams of oxygen, and that gives me 23.49 grams. So this kind of a conversion you should really be familiar with to do more difficult questions. Similarly, I calculated the grams of potassium chloride also. Using the grams of potassium chloride, I converted that into moles of KCl and grams of KCl, and I get the mass of KCl. For the reaction SO2 plus Cl2 giving you SoCl2 and Cl2O, we have asked him to do various questions. So the equation is already balanced. The first thing is calculate the moles of Cl2O produced from 3.30 moles of chlorine and enough SO2. The second one is moles of chlorine needed to produce 4.20 moles of SoCl2. So the first question, I need to know how much of moles of Cl2O will be produced. So I have 3.30 moles of chlorine. Convert that into moles of Cl2O using the equation, and I get 1.65 moles of Cl2O. The second part is also easy. I need to know how much of chlorine is needed to produce 4.20 moles of SoCl2. So start with the 4.20 moles of SoCl2, and using the equation, 2 moles of Cl2 gives you 1 mole of SoCl2. I can calculate the moles of SoCl2 also. This is a kind of easy question. So consider as a warm-up question before we go into difficult questions. The equation is ammonia reacting with chlorine to give you N2Cl4 and HCl, and they have asked you to calculate the grams of N2Cl produced for particular moles of ammonia and excess chlorine, and another one is calculate the grams of ammonia needed to react with excess chlorine. So the first part is we need to know how much of N2Cl4 will be produced from 4.40 moles of ammonia. So use the equation. Start with 4.40 moles of ammonia, convert that into moles of N2Cl4, and convert that into grams of N2Cl4, and you get the answer. The second one says calculate the grams of ammonia needed to react with excess chlorine to produce 112.25 grams of N2Cl4. Now I know how much of N2Cl4 is formed, so start with that. Convert that into moles of N2Cl4, then convert that into moles of ammonia, and then using the equation, and then moles of ammonia can be converted into grams of ammonia, and I get the grams of ammonia needed to produce the required amount of N2Cl4. Calculate the grams of ammonia produced when 4.25 grams of nitrogen reacts with the required amount of hydrogen. So the first thing is write down the equation and balance it. This is not a difficult question. Start with 4.25 grams of nitrogen and then convert that into moles of nitrogen, and using the equation convert the moles to moles of ammonia, and once I have the moles of ammonia I can convert that into grams of ammonia, and I get that as 5.17 grams. Calculate the mass of potassium carbonate that reacts completely with 10.25 grams of nitric acid to produce potassium nitrate, carbon dioxide and water. As always, write down the equation. You should know how to write the formula of the reactants and the product. So we have to find out the grams of potassium carbonate. So start with the 10.25 grams of nitric acid, convert that into moles of nitric acid, using the equation, convert that into moles of potassium carbonate, and then molar mass of potassium carbonate is used to get the grams of potassium carbonate. Calculate the grams of iron 3 sulfate produced when 24.52 grams iron 3 nitrate reacts with sodium sulfate and produces iron 3 sulfate and sodium nitrate. So write down the equations, and iron 3 nitrate is FeNO3 thrice, iron 3 sulfate is Fe2SO4 thrice. These formulae you should be familiar with. Write it down and then balance it. And once you write the equation and balance it, the whole process becomes simple. You need to calculate the grams of iron sulfate produced. So start with 24.52 grams of iron nitrate and convert that into grams of iron sulfate using the equation, and you can get the answer. So these kind of a question, the hard part is to write the equation correctly and balance it. The rest of it becomes easier. Calculate the mass of sodium carbonate needed to react with the required amount of calcium nitrate to produce 64.3 grams of calcium carbonate and sodium nitrate. The reactants and the products are given. So write down the equation. Sodium carbonate plus calcium nitrate giving you calcium carbonate and sodium nitrate. The formula are given over there, and then balance it. And then for the given grams of calcium carbonate, for 64.3 grams of calcium carbonate, calculate the grams of sodium carbonate. The steps are given over there. Is the usual one. Convert that into moles of calcium carbonate, then moles of sodium carbonate, then grams of sodium carbonate, and you can get the answer.